Teams often learn this the hard way. A polyacrylic acid that seems like it will work suddenly causes issues once it reaches electronics manufacturing. Qualification stalls, yield slip, or performance drifts during scale-up even though the material meets spec. This is the first video in a short series on why not all polyacrylic acid is electronics ready. What teams often miss is that polyacrylic acid can share the same chemical name and even similar molecular weight targets, while behaving very differently in contamination-sensitive electronics processes. On paper, the differences can look minor. In practice, they show up late, during qualification, extended production runs, or after scale-up, when the material interacts with metals, oxides, and engineered surfaces under tight process windows. That's because electronics-grade polyacrylic acid isn't defined by a single line on a certificate of analysis. It requires verified control over purity beyond basic chemical specs, trace metals that influence surface interactions, and consistency across manufacturing at scale, not just at the lab level. A material can meet incoming specifications and still introduce variability once it's inside a real electronics process. At Polysciences, we work with electronics teams to determine whether a polyacrylic acid grade is truly suitable for their process, and to identify where risks tend to emerge before they become costly qualification or yield problems. If you're qualifying or scaling polyacrylic acid for an electronics application, our team is ready to help. Visit polysciences.com to contact our technical team, and stay tuned for the rest of the videos in this series.